Hello students, welcome back to my channel. So this is a new playlist which I have started where we will be discussing about number systems. In the previous session, that is in the very first video, we had discussed about what is the meaning of number system, what are the different types of number systems, etc. In today's sessions, we will be learning about conversion between these number systems. Especially, we will be focusing about how to do the conversion from a decimal number to other number systems. That is, other number systems is nothing but binary, octal, and hexadecimal. So how can we do the conversion between these two number systems? So today we will be briefly discussing with few examples. In the coming sessions, we will discuss more examples and we will see how can we do the conversion between these two number systems. Okay, so the basic steps, 4 steps in order to do the conversion from decimal number to other number system is we will divide the number by the base value of the number system in which it is to be converted. Mean to say, suppose if I want to convert my decimal number into binary, then I will divide the given number. For example, if given number is x, it is in decimal form, I have to convert it into binary, then I will divide this by 2. That is the base of the system, base of the number system to which I want to convert. If I want to convert x into octal, then I will divide it by 8. That is the base of the octal number. If I want to convert x to hexadecimal, then I will divide it by 16. So this is how we will do it. So once we do the division, we have to, at each step, we have to note down the remainder of each step. Then keep on dividing the quotient. Remember, we are going on dividing the quotient by the base value and note the remainder until the quotient is 0. That is how we will do it. Then what we will do is write the noted reminders in the reverse order. This is the basic step to convert the decimal number to any other number system. So let us see one by one. First, we will see how to convert a decimal number to a binary number. The very first example, what I'm going to take is number 65. So if we have to follow the steps, then if I want to convert it into binary, then the base of binary is 2. So I'm going to divide this number by 2. So this is how we will write it. So how it is going to be done. So I'm going to write the quotient over here and I will write the remainder over here. Now, how will I divide? The regular division you will do. How do you do the regular division? Here I will take the very first number 6. I will divide 2 by 6. So I will get 3 as a quotient. 2 divides 6 3 times and I will get 0 as a, so 2 3s is 6. So I will get remainder 6. Next I will take 5 over here. Now 2 divides 5 2 times and I will get 4. 2 2s are 4 and 1 is the remainder. So instead of doing all this, so here we will do in a shortcut form. So 2 divides 65 32 times. This is the quotient. And what was the remainder? The remainder was 1. Okay. Next again, this 32, the quotient, whatever we are getting, again I'm going to divide it. Like we saw in the step, I'm going to divide it until I reach 0. So 2 divides 32. So I will get 2 1s are 2. So 12 I will get. So this is 12. And then I can say I will get here 16. So 2 divides 16. 2 16s are 32. I will get 0 remainder here. Okay. Again, once again, I will divide by 2. Now 2 divides 16 8 times. Remainder is 0. 2 4s are 8. Remainder is 0. 2 2s are 4. Remainder is 0. And 2 1s are 2. Remainder is 0. Now, in some method, you will also see that it will be written further divided and it will be written 0. You need not write that. You can directly write this in the reverse order. So what will I get if I write it in the reverse order? I will get 1, then this one 0, then this one 0, then 0, 0, 0, 1. So I have 1, 1, 2, 3, 4, 5. 5 zeros and 1. Now this is the converted. So 65, which was of base 10, is being converted to binary number. So this is how I'm going to do the conversion of a decimal number into binary. Now let us take another example. Let us take 122. All right. So 2 divides 6 times and then 2 61s are 122. Remainder is 0. 2 30 So 30 to the 60, remainder is 1. 2 15 times we will get 30. So remainder is 0. 2 7s are 14. I will get remainder 1. 2 3s are 6. I will get remainder 1. 2 1s are 2. I will get remainder 1. So if I have to convert 122, which is in decimal, into binary, then once again write it in the reverse order. I will be getting 1 1 1 1 0 1 0. This is in base 2. So this is how I will convert my any given decimal number into binary conversion. All right, I hope this is clear. Next, let us see next conversion, decimal to octal conversion. How can I convert it into an octal? Again, once again, octal means it is base 8. So as we discussed, if at all I want to convert, for example, I will take the same example, 65. If I want to convert it into octal, I will take 8 as a number with which I'm going to divide. So 8 8s are, we will get 64. So 1 reminder, 8 1s are 8. So 0 reminder. So a 65, which was in a base decimal, is being converted into octal, and now this is in an octal form. Don't think that this is because it is 101, it means that it is in a binary, because we know that in octal 0 to 7 digits are allowed. All right. We'll take one more example with that, it will be clear. Let us take 122. Now 8 15s are 120. So we will get 15 here. 8 15s are 120. So 2 reminder. 8 1s are 8. We cannot divide by twice because it is not 16, it is 15. So 8 1s are 8. So 1 and 7 is the remainder. So since we have reached here 8, we can stop here and I will write it in the reverse order. So 122, which was in decimal, now is converted to octal and it is written as 172 to the base 8. As we have discussed previous session that in octal we can have only digits 0 to 7. As you can see, we have only 172. We do not have any number which is 8 or 9, etc. Okay, so this is how I will do the conversion from decimal to octal. Next, let us do the conversion of decimal number to hexadecimal conversion. So once again, hexadecimal is nothing but base 16. So we have to divide the given number by 16. Let us take the same example, 65. If you want, you can pause the video and do it yourself. All right. So 16, if I have to divide 65, 16 fours are 64. Hence, I will write 16 divides 65 4 times and remainder is 1. Hence, so since it is 4, I can end here. Okay. Or else if you also want, you can further divide 16. It divides 0 times 4 and 4 is the remainder. It is one at the same. So you will take this. Otherwise, you will write it in this order. So 65, which was in a decimal order, can be now written as 4 1 when it comes to the hexadecimal. This is the conversion. Let us take the next example, that is 122. If I have to convert 122 into hexadecimal, then 16 sevens are it is 112. Okay. So if I have to subtract 122, then remainder is 10. Now 10 in hexadecimal, we know that I will write it as 8. Okay, because 0 to 9 we have a number and after 9 we will write A, B, C, D, E, F. Until F we have those numbers in hexadecimal. So 16 divides 122. How many times? 7 times. And what is the remainder? Remainder is 10. That 10 I'll be writing it as A. All right. And so this is how, so since it is 7, I can end it here. So the converted number is 7A. Or else you can also further divide and say 16 divides 7 0 times and 7 is the remainder. So this time you will take it as 07A, which 0 you can ignore. Okay. So once again, it will be 7A. So 122, which is base 10 decimal number, is being converted into hexadecimal and it looks like 7. This is the converted hexadecimal number. Okay, I have tried to explain it to you as simple as possible. I hope this is clear. So first, you please kindly master decimal to other number conversion so that your basics are strong. So once this conversion is done, then converting from binary to decimal or hexadecimal to decimal or octal to decimal will become easy. So once this conversion is done, then we can do between binary, hexadecimal, and octal. These conversion we will be doing in the coming sessions. All right. So that's all in today's session, students. Thank you for watching.